Okay, so this first set of calculator work is very, very easy. It says evaluate with the calculator and round to the 10,000. Now, 10,000. How many decimal places am I going to carry?
5. 3.
What's the difference? 4. 10,000th is 4 places. Boys and girls, what decimal place is that?
1.
That's tenths, right?
Oh.
2 tenths. This one is the hundredths. This one is the thousandths. And this one would be the 10,000. So we're going to round to the nearest 4 decimal places. Did everybody find your log button? Your LOG button right here in the first column? So you don't need to do anything except press the buttons. So log 8.61.
Do we need to close the parentheses?
You actually don't, as if that is all you're doing. If there's more to the problem, you do. So it's probably good to get the habit of closing it, but you really don't have to in these exercises. So what did we get for A? 0.9350. And I'm going to go ahead and add that 0 on because my directions did say to round off to the nearest thousandth. So I'll have 4 decimal places. Okay, would you go ahead and type in the rest of them and then give me the answers and we'll talk about them?
B is 2.4.
Well, what I thought you might do, Ferris, is do them all, write them down on your paper. But since you have that one, what is it?
2.4849.
Okay, now the rest of them would you just do on your own and write down? And then we'll give a list of the answers up here.
What's 4? For C,
okay, let's just keep going. Just keep going. We're gonna talk
It won't
about
let me do it.
Okay, we'll skip it and go on then. Okay, well, if something goes wrong or doesn't seem to be working, just skip that one and go on to the next one. Zion, are you okay, sweetie?
Yeah.
Okay. If you need to elevate your leg or something, you're allowed to do that. Not you.
What?
I must have turned it in a scrap the other page.
Okay, who has an answer to C? No one has an answer to C
Were we supposed to put
because
1.9?
there isn't an answer to C. Here is what I want you to think about, you guys. The problem literally says log base E of -9 equals what, right? So the calculator is saying, okay, e to some power is a -9. Now, I want you to think about this. Can you raise a positive number to any power and make it negative? No. In other words, kids, when you have the log of a negative, it will never work. You can't ever take the log of a negative. So what did F turn out to be? No solution. G, no solution. You simply can't do it. You can't take the log of a negative number. Now, you should have gotten an answer to D. What did you get to D?
1.1895.
1.1895? I'm looking for agreement.
Yes.
What did you get for E?
-3.
-3.1355. And H? 3.2960. 3.2960. Good job. Now, just shared a tad bit of a history lesson with you. I took I took this class when I was in school, like you. Only we didn't have calculators, of course, back in the dark ages. So instead, we all had to buy, you know how you all had to buy a calculator? We all had to buy this book. It's called the CRC table, and it is full of everything your calculator will do is in here in a table form. So if I wanted to find the square root of 2, you just press the buttons. If I needed the square root of 2, I either calculated it by hand, and they taught us the procedure, and it takes forever, or I got out my CRC table and looked it up. So this exercise for us was an exercise of just looking numbers up in the table. Now, the interesting thing is you had to be kind of a table expert, because the logarithm tables, and there are LN and LOG tables, both in here, natural log and common log tables, but they don't have every single number in the whole wide world. So for example, this one down here, find the log of 1977, I couldn't find that. That number is not in my book. So what I had to do was change this into 1.977 times 10 to the third. Okay? That 3 is that 3. So then I had to look up in my table the log of 1.977. And that would give me this part. Except my table didn't have 1.977. My table had 1.97 and 1.98. So then I had to, by hand, do a process called interpolation, where I figured out what the value was that was for that 0.977. So when you people start whining and complaining, put yourself back 40 years ago, and I'll tell you, 45 years ago, and I'll tell you, it was a whole different world. And everything took forever long. This is not my CRC table. Mr. Mauger gave me his. This is actually Mr. Mauger's. Mine's brown. It's over there somewhere. But everybody had one back in the day. Everybody had a CRC table.
Is that why you're a superior math teacher? Because you know the CRC table?
I don't know the table at all. But I'll tell you what, when I first came to Cathedral, detention was handled. Every teacher in the building had to do detention on a revolving basis. So when it was my week to do detention, the kids copied the logarithmic and trigonometric tables.
I would not have done it.
Do you remember giving my dad everything?
No, but I'm sure I did. I've written many detentions in my life. I don't remember specifically giving him one, but I wouldn't doubt that I did. I probably did. Okay.
Was it a choice?
When did the first calculator come
out? Take like that class, this class?
When I first started here, yes.
It was a choice.
It was a choice. But
so you chose to use it.
No, when I was in school, well, it was a choice, but it wasn't a choice for me. I was going to college, so of course I'm taking the class. But no, when I first started at Cathedral, pre-calculus, there was only one level, so everybody took the same pre-calculus class.
When did you start teaching it?
81.
So yeah,
Yep, I remember them very well. Jen, I love you.
All the teachers love them.
Okay, now we're going to solve some equations. We don't necessarily need a calculator for most of these, I don't think. We might need them for something. But here we go. So we're going to solve this equation right here. Remember, when you see LOG, you're going to pop in a 10, right? Right?
Right.
So now let's loop-de-loo it. What's the answer to the question going to be? 10 to the third equals x. You shouldn't need a calculator for that. 10 to the third is 1,000. All right, let's try this one. Again, the base is 10. Remember, if there's no base, it's always 10. So loop-de-loo it. 10 to the negative first equals x. What does 10 to the negative first mean? 1 over 10? What's this one say? 10 to the negative second equals x. What's 10 to the negative second?
1 over 100.
1 over 10 squared, which is 1 over 100. Yep, you're exactly right. Perfect. Beautiful.
Nicely done, guys.
Now, we may need a calculator here. Let's take a look at this. ln x equals 4. Remember, what does ln stand for? Log base e. So we can loop-de-loo this and say e to the 4th equals x. In some cases, it's perfectly fine to leave e to the 4th. In other cases, we may want a decimal, so let's practice it. Sometimes this would be okay, but sometimes we want a number, so let's practice it. On your calculator, you actually have an E button. Does anybody see it?
Yes.
Where is it? It's right over ln. So if you do second ln, it pulls up E, and it says what power do you want? Type in 4.
50.
And the decimal is 54.5982. So where do we get, if we need a power of E, where do we get it? Second ln.
Do we always have to do it around the nearest 10,000?
No, I just am because that's what those directions said. All right, how about letter E? Log base E equals 6. So what does that one say? E to the 6 equals x. So if we don't have a calculator, that's the answer. If we do have a calculator, what did you say it was? 403.4288. Corey, be quiet, please. Mason needs to pay attention. All right, I'm going to pop a base 10 in there just so I don't forget it. You got a couple of options, but I think I would divide both sides by 3 to start with, so that I don't have to worry about that anymore. So I have log base 10 of x equals 1. Right? So 10 to the 1st equals x. So the answer is just 10.
Could we not do the where like
What if you didn't divide by 3?
yeah?
Then you would have to know your property of logarithms. It says that's really an exponent, so I'd rather you just divide it by 3. If we have an equation, let's divide to get our variable by itself if you can at all. So when I do this one, I'm going to do exactly the same thing. I'm going to divide both sides by -2. So what does my equation say? ln x equals -2. That's log base E equals -2. So when I loop-de-loo that, what does it say? E to the -2 equals x. What's e to the -2 mean? 1 over e squared. So on a no calculator exercise, this is the answer. You are finished. If it's a calculator exercise, then we can figure out what that is.
0.1353.
That's exactly right. 0.1353. Yep.
Would it
that's
not be over 1? No.
No. That is just it. Does any anybody feel like you know what the answer to H is? What is it, Judah? Exactly. 10 to the 1/2 equals x. If we loop-de-loo it, 10 to the 1/2 equals x. And Judah remembers, what does a 1/2 exponent mean? Square root, right, of 10 to the first. So on a no calculator part, square root of 10 is the answer. On a calculator part, 3.1623. I and J are exactly the same, except they won't be square roots. What's this one say when I loop-de-loo it? Max, loop-de-loo this, what's it say?
I was gonna say,
10.
yeah, 10 and 10 to the 3.
1/3. 10 to the 1/3 equals x. 10 to the 1/3 equals x. So what does that mean? 10 to the 1/3?
You're gonna cube root.
Cube root it, so the cube root of 10. Do you remember the other day we did some cube roots, so we did some roots on our calculator? So we put in the 3, and then our math button, go down and pick up the x root, type in 10, and you should have gotten 2.1544. Actually, most of your calculators probably have a cube root button, but you can do it using the x root button if you want. That's how I do it.
Where is the X root?
It's in the math menu, exactly where it was last time we talked about it. So, if we don't have a calculator, we have to stop here. If we have a calculator, we can do this. All right, last one in that section says ln x equals 1/4. So that's log base e So let's loop-de-loo it. Max, what's it say?
It says e to the 1/4 equals x.
Bingo, that's what it says. And what does e to the 1/4 mean? Okay, you two, you always blame Jalen, but this is not on Jalen.
No.
No. This is on you. Now stop it. E to the 1/4 equals x. What does that mean? What's e to the 1/4? 4th root of e. Don't fractional exponents mean radicals? So now, I'm going to give you a little hint. If you're putting this in on your calculator, you can either put it in as an exponent, or you can put it in as a radical, whichever is easiest for you. I like to just second ln 0.25. But however you do it, see if you get 1.2840. That's what you should end up with. One-fourth decimally is 0.25. So e to the 1/4 is like e to the 0.25. I can type that in instead of using my radical sign. Okay? All right, we're going to plow through some more notes, and then we're going to do some review next time we're together. But since we're a little behind, we need to keep forging ahead. So, section 3.4 talks about writing as a single logarithm.
Sorry, turn around.
So, before we can do that, we need to talk about three very important properties of logarithms. Max, I know you're thinking about Thanksgiving dinner, but I really need you to be focusing up here. Okay. So somewhere, maybe along the side here, if you have room, let's make a list of these three very important properties because they're what's going to help us do the rest of these problems. Okay? So one of the properties says that if you have the log of m times n, that will be the log of m plus the log of n. So in other words, if you take the logarithm of a product, two numbers times each other, you can pull that apart, but when you pull the times apart, it becomes an addition. Similarly, if you have a division, m over n, we can pull that apart, but guess what it becomes? Multiplication became addition, so division is going to become subtraction. You're making a note of these, you're writing these down. And the last one, the last property says, if you have a coefficient out in front, like we did in some of our problems a bit ago, one way to get rid of that coefficient is to divide. That's what we did. But another way to get rid of it, Ferris, my dear, pay attention. Another way to get rid of it is to think of it as an exponent. So in other words, this guy pops off and becomes an exponent. If we get these three ideas down, we should be able to do section 3.4. One A says the log of x minus the log of y. Two logarithms. I'm supposed to mush those together and write one logarithm. My properties allow me to do that. If I see a subtraction, I know I can put those together into a division. So this would be the log of x over y. So, Zion, quit shaking your head. This isn't hard. If we have a log minus a log, we can put those together, and when we put them together, they become a division. If we were putting together an addition, it would become a multiplication. Okay? So, look at the next one. 2 log x plus log y. Now be careful. This is a problem. What does our property tell us we can do with coefficients that are out in front? They become exponents. So this could be the log of x squared plus the log of y. This 2 becomes an exponent on the x. Now, I need to put these together into one logarithm. The direction said one logarithm. So I'm going to take these two expressions and I'm going to put them together. Now, they're an addition. So when I put them together, they will be a multiplication. So this is going to be the log of x squared y. Getting the hang of that a little bit? All right, so next. Oops, I'm erasing my properties. I hope you have them written down. 1/3 log Z plus log W. Where do you think I need to start? Think about the problem we just did. Judah? Well, I'm going to do a multiplication, but I can't start that way. I got to take care of that first. Where does that go? Francie?
Make the 1/3 exponent.
Exactly. So this is going to be the log of Z to the 1/3. Right? Now can I put them together?
Yeah.
Yes. And like Judah said, when I put them together, they're going to go together as a multiply. Why are they going together as a multiply? Because it's an addition. And adds go together as multiplies. Subtracts go together as divides. Speaking of subtracts, we have one here. We're going to be done soon, folks. Hang on, you're doing great.
Is that the same thing you make both of them exponent?
Okay, so yes, so we've got now two coefficients to worry about. So we're going to take this one and put him up here. And this one and put him up here. Does that look okay to everybody?
Would it just be x, y, the fourth over x?
So far so good? Now I'm going to put them together and write one logarithm. So instead of having two logs, I only have one log. And when I put them together, because that's a minus, it's going to be a division problem. Would you agree with that? But we're not done this time. Do you notice anything about that? You can cancel. This actually simplifies, doesn't it? So let's simplify it. This would be x to the fourth, y to the fourth over x cubed. Remember, that exponent goes with both of these. Now I can cancel. So what am I going to be left with here?
X, y to the fourth.
X, y to the fourth. That's the final answer. Good job. Let's do a couple more.
I mean, it's kind of, he's a scout, so it's like.
Stop talking. Unless you're talking about math. Max, focus, man. What's going to happen here? I'm going to put these together, Max, into one logarithm. Right?
Yeah.
That's an add. So when I put them together, it's going to be a multiply. So I'm going to have 4 times 7 or 28. That's the answer to the question. Put them together. How about this one? Gonna write them as one logarithm. Put them together. What is it? It's 2. Because don't you divide the 16 and the 8? So that's just going to be the log of 2. How about G? Come on, stay with me so you get to leave here. ln 19 minus ln 8. What's going to happen?
Subtracting log e.
I'm going to divide, so it's going to be ln 19/8. That's not 2. It's 2.375 or something like that, but it's not 2. And the last one, I'm going to let you go, but not till we get through this one. Here we go.
Is it 2 to the 2 cubed?
Okay, so ln 2 cubed,
Times.
which is going to be ln 8,
Yeah. And then
plus.
times square root of 36.
Very good, Harris. This comes off here, So it'll be ln 36 to the 1/2, which means the square root of 36. So I have ln 8 plus ln 6. And what do I do with those when I put them together?
48.
It's ln 48. Now remember, kids, it's not just 48, it's ln 48. You're taking two logarithms and making one. All right, I'll see you tomorrow. We'll do some review and catch up. Have a great day.
What's the homework?
I don't even know if it's going to be due next week. No earlier than the very end of next week. I got